Measures of position, but I'll start out with percentiles. Roughly speaking, the pth percentile is the data value that is more than p% of the data. So, for example, the 38th percentile would be the data value that is more than 38% of the data. And different books do it differently, so you may get slightly different answers depending on what method you use, but I'll go over the method that our book uses. Okay, so this example here, we have a set of 12 exam scores, and 80, 88, 28, 91, 65, 88, so forth. And for measures of position, whether it's percentiles or another measure of position, the first thing to do is put them in order from smallest to largest. So in order from smallest to largest, we have 28, 59, 65, 78, 80, 82, 83, 88, so forth. And then the ranks, the rank of the first score, the lowest score is going to be 1, the rank of the second lowest score will be 2, and so forth. So we have 12 exam scores, N is 12, P is our desired percentile. We want to find the 20th percentile, so P would be our desired percentile. Desired rank is N times P over 100. So this is going to be 12 times 20 over 100. So that's 240 over 100. That's 2.4. And percentiles, we want to always round up. So we want to take the third ranked score. The third ranked score is going to be 65. So the 20th percentile, or P20, is equal to 65. You've probably seen other ways of rounding where if the digit next to the round off digit is 5 or more, you round up. If it's less than 5, round down. But we're following a different rule of rounding for the percentiles. 2 point anything, 2.1, 2.4, 2.006, or what 2 point anything is going to round up to 3. That's when you're computing percentiles. Okay, 25th percentile, P25. This is also called the first quartile or the lower quartile. So desired rank is going to be 12 times 25 over 100. So that's going to be 300 divided by 100, which is 3. Now, if the rank comes out to be a whole number, we're going to take the average of that rank and the next higher rank. So the average of the third and fourth ranks. So if we go to our scores, the third ranked score is 65, the fourth ranked score is 78. So it can be 65 plus 78 divided by 2. 8 plus 5 is 13, carry the 1, 167, 143, divided by 2, 71.5. So our 25th percentile. Now, if it's more than 25% of the data, that's going to be more than 1/4 of the data. So that's also called the first quartile. So it's P25 is also equal to the Q1 first quartile, and it's 71.5. Okay, 50th percentile. This is also going to be the same as the median or the second quartile. It's also called the middle quartile. So the 50th percentile is going to be, we have 12 scores, 12 times 50 divided by 100. It's going to be 600 divided by 100, which is 6. So again, when this comes out to be a whole number, if it comes out to be a decimal, you round up. If it comes out to be a whole number, take the average of that rank and the next higher rank. So the 6th and 7th ranked. So if we go to our list here, 6th rank score is 82, the 7th rank is 83. So it's going to be 82 plus 83 divided by 2, that's 165 divided by 2, 82.5. So that's the 50th percentile. It's also the median. It's also the second quartile. More than 2/4 of the data. Okay, this 75th percentile. So again, it's the formula for the rank is n times p over 100. So 12 times 75 over 100, 900 over 100, 9. Again, this is a whole number, so we want to take the average of that rank and the next higher rank. So we want the average of the 9th and 10th. So if we look at our scores, we have 88 and 89. Average of 88 and 89. So 8, 9 is 17, carry the 1, 1, 8 is 9, 8 is 17, divided by 2, it should be 88.5. So that's P75, that's also the third quartile. More than 75% of the data, or it's more than 3/4 of the data. Okay, so there's a graph that's based on the quartiles. This graph loses a lot of the information. It only has, it's based on 5 numbers. It doesn't matter if you start with 12 exam scores or 100 exam scores. You're going to end up with 5 numbers, so a lot of the detail is not going to show up in this graph. But sometimes that's going to be an advantage because sometimes the details get in the way of seeing the overall pattern. And the big advantage of this type of graph that's based on the quartiles is that it's very good at showing symmetry versus skewness. So anyway, the minimum, that's like the 0 quartile. If you want, you can call that Q0. So these are, you can think of this as basically essentially a graph of the quartiles. We have Q1, median is the same as Q2, Q3, the maximum we can regard that as Q4. So basically, so we want to make a box going from Q1 to Q3, and the whiskers go out to the Q0 and Q4. So the box, so these numbers here are the box. It's 71.5 up to 88.5. That's the box. And the line inside the box is for the median. So at 82.5 we have the line inside the box, and the whiskers go out to the minimum and the maximum. So we have a minimum of 28 and a maximum of 92. So that's our box plot. And if you look to see where the median is, there's going to be a lot more to the left than there is to the right. So this tells us the graph is skewed left. So it's the big advantage of the box plot, or the box and whiskers plot, is that it very clearly shows skewness versus symmetry. Some of the questions of WebAssign that sometimes confuse students, they'll ask something like, well, the middle 50% of the data are between what 2 numbers? Well, the middle 50%, the middle 50%, that goes from Q1 to Q3. That's the middle part of the graph. So that would be between 71.5 and 88.5. Or they might say, what is the lowest 25% of the data are between what two numbers? Well, that's the first quartile. It's between 28 and 71.5. That's 25% of the data. So there's 25% of the data is between each of the quartiles. So the 25% of the data, or 1/4 of the exam scores, are between 28 and 71.5. 25% or 1/4 of the scores are between 71.5 and 82.5. 25% of the exam scores, or 1/4 of them, are between 82.5 and 88.5. Another 25%, or 1/4, are between 88.5 and 92. So anyway, there's some of the questions the web assign will ask you for those kinds of percentages. Okay, the range. There's these. We're getting into measures of spread, but the some of the easier measures of spread are based on measures of position, and we'll get into more detail on some of the other more important measures of spread in a different lecture. But anyway, the range is one of the easiest measures of spread to compute. It's the maximum minus the minimum. The maximum score is 92. The minimum is 28. 92 minus 28 is 64. The range, okay, so that's the range. The range has the disadvantage of that if you, it's very much affected by an outlier. So if this 28 were, let's say, a 68 instead of a 28, then the range is going to be 24 instead of 64. It's going to make a big difference in the range. So one way around that is called the interquartile range. It measures how spread out the middle part of the data is. So it's going to be Q3 minus Q1. So that's the measures how spread out the middle part of the data is Q3 minus Q1. So it's 88.5 minus 71.5, and that's 17. So that's how spread out the middle part of the data. And that's not going to be affected by outliers. Okay, so there's previously we were in our graphs we're kind of just eyeballing the data to decide if it's an outlier. There are some more precise methods of determining outliers. So we were first just sort of eyeballing it from the graph, but method 2 is based on the quartiles. So if you do the that's going to be Q. I think this is wrong here. This is Q1 minus 1.5 times the interquartile range, and this is Q3 plus 1.5 times the interquartile range. So this is going to be Q1 is 71.5 minus 1.5 times the interquartile range we just computed was 17. So if we do 71.5 minus 1.5 times 17, I get 46. And then Q3 plus 1.5 times the IQR. So that's going to be Q3 is 88.5. 88.5 plus 1.5 times IQR. 88.5 plus 1.5 times 17. I get 114. 46. Okay, so outliers would be, if for this more precise method, outliers would be values that were scores that are either above 114 or below 46. And there's only one. We had a score of 28. That was the only score that was below 46, we didn't have any scores that are above 114. So in this case, we have one outlier. In some cases, you might have more than one outlier, but for this data set, we just have the one outlier. There's also a method based on z-scores, which we'll get into a little bit later. A z-score below -2 or above +2 is moderately unusual. A z-score below -3 or above +3 is an outlier. But we'll get into more of that later. And then there's a type of graph called a modified box plot that takes into account the outlier. So instead of having the box is going to be the same, but the whiskers, instead of going to the lowest exam score or the highest exam score, they'll go to the lowest exam score that's not an outlier, and they'll go to the highest exam score that's not an outlier. So take a look at our data again here. The lowest exam score that's not an outlier would be 59, and the highest exam score is 92. That's not an outlier. So the whisker goes to down to 59 instead of going on to 28, and then we put a little asterisk, or sometimes they put a little O there to indicate an outlier. So that's called a modified box plot. It's still going to be skewed left, but it's not as skewed. The tail on the left is not as long. So anyway, it's in some books we'll use a little O for minor outliers, a big O for major outliers. A major outlier would be three interquartile ranges away from the quartiles. Okay, so that concludes this presentation.